Share screen. Start. Now we got it. Thank you. So the first thing we're going to work on is multiplication and division. And the rule is that the answer to multiplication and division problems will have the same number of significant digits as the measurement with the fewest. The part I keep in mind with multiplication and division is same number of significant digits. The next one, the next rule, is a rule for addition and subtraction. This rule is that the answer to addition subtraction problems will have the same number of decimal places. As the measurement with the fewest. With this one, I keep in mind same number of decimal places. The last one rule that we will talk about has to deal with multiple orders of operation. And in that case, the first thing we do is we follow PEMDAS. Parentheses, exponential, multiplication, division, addition, subtraction. Whoops. Now, when we're working with PEMDAS, you follow this direction. However, when it gets down to the multiplication and division, if you have multiplication and division in the problem, you move left to right. The same thing is true for addition and subtraction. If you have multiple orders of operation of addition and subtraction, you will move left to right through the problem. Now, here is the tricky part. As you perform these calculations, you have to be prepared to make note of the number of significant digits that should be retained after each step but do not truncate or do not round. Until the entire problem is done. Finally, we do round. And there's actually a bigger variety of rules than what I'm going to make you know. But with respect to rounding, the only rules that you need to know are the rules that, well, I forget when it's taught, but 4 or less, let it rest. 5 or more, let it score. So in other words, you don't round if the digit following the last digit you need is 4 or less. We do round if the digit following the last digit we need is 5 or more. There's actually rules for fives, and there's rules for natural logs, and there's rules for logs. There's a lot of different rules, but we're just going to keep it simple. If you continue into chemistry and you take quantitative analysis, then you can be introduced to the other rules. But otherwise, we keep it pretty simple. Okay, now it's time for me to illustrate and do a few problems. So we're going to record our answers to the correct number of significant digits for the following problems. The first problem is 3.461728 plus 14.91 plus 0.980001 plus 5.2631. One of the easiest things to do when you're dealing with addition and subtraction, which this is, so that's the first thing I would have done is go, okay. Where are you? The first thing I would have done is I would have gone, okay, this is addition and subtraction. So it's the decimal places that matter. Now, with addition and subtraction, the easiest way is to actually put this in a column format. 3.461728, 14.91, 0.980001, and 5.2631. And this is all addition. And so since it's the decimal places that matter, we're going to draw a line after the one with the fewest decimals. Then we'll add this up. When you add it up, you get an answer of 24.614829. Looking at the digit to the left of, or to the right of what I want to keep, it is less than, it's 4. So therefore, the answer that I would record for this problem is just 24.61. Let's look at another example. 22.101 minus 0.9307. Again, I notice that this is addition and subtraction. So it's the decimal places that matter. Since this is just addition and subtraction, I'm going to put it in a column format. And I am going to mark the one with the fewest decimals. Come on. Now you're being stubborn. And then do the math. When you do this math, you get an answer of 21.1703. Looking at the digit we need to drop, the first digit we're dropping, it's a 3. So again, this one is not going to be rounded up. It is just going to be recorded as 21.170. Questions about addition and subtraction? It rolled up here. Oh, okay. Let's look at another problem. Let's do 6.085 divided by 2.33 times 2.1. This one I notice is multiplication and division. So it's total sig figs that matter. I also notice that this problem has both multiplication and division in it. So I'm going to move from left to right. When you key this into the calculator, you get an answer of 5.4843347764. Now, because it was total significant figures that matter, we look at the value with the fewest. The value with the fewest only has 2 sig figs. And so our answer is only going to be allowed 2 sig figs. Looking at the number that is to the right of that, it is more than 5. It's 5 or more. So so this answer would be recorded as 5.5.
You don't have to worry about like actually solving this out.
No. Use your calculators. Yes.
That's the question.
What now?
That's the question. I think there are 4 significant numbers. Minus 3 over 7.
There should only be 2 because according to the rule for multiplication and division, your answer will have the same number of significant digits as the measurement with the fewest. The measurement with the fewest only had 2 sig figs. So our answer can only have 2 sig figs.
Last one. Start level before that.
This is addition and subtraction. And it's the decimal places that matter. You have 3 decimal places, you have 4 decimal places. The one with the fewest has 3 decimal places, so our answer can only have 3 decimal places. So it isn't the number of significant digits with addition and subtraction, it's decimal places. So that's the difference is addition, subtraction, all you're paying attention to is the number of decimal places you should record. Multiplication and division, it's total sig figs.
Is that why you put the line after 3?
That is the why I put the line after 3 is because I was trying to figure out which one had the fewest. Because my answer can only have that many. Other questions? Let's look at another example. And with this one, I'm going to introduce another thing with your calculator, if you have it. If you don't, I will write it out so that you can go back and do it. And that is, we are going to do multiplication and division with two numbers in scientific notation. So again, this is multiply and divide. So it is the sig figs that matter. Now, let's talk about how to, you can enter this into your calculator in two different ways. One way, if you forget anything, it can mess it up. The other way, if you learn it, usually you're not going to ever have issues with scientific notation. So the way most people have been taught to enter this into their calculator is open parentheses 4.52 times 10 raised to the -4 divided by open parentheses 3.980 times 10 raised to the -6. Does that, it may be different for some places, but does that look familiar? Here's the problem with that way. If you forget a parentheses, you can completely mess up your problem. And you will get the wrong answer. So let's look at a way where you don't have to worry about those parentheses. For me, this is the better way, simply because most students make fewer mistakes. You type in the 4.52. And I know this on TI calculators, if you have something else, we'll have to look. But then you use your second button and your comma. And then a -4. Divided by 3.980 second, comma, -6. The comma button is, the comma is right above the 7 on most of the calculators. You don't have to worry about parentheses. Now, what does it look like on the calculator face? The way it'll appear is 4.52 e -4 divided by 3.980 e -6. When you key this into the calculator, you'll get a value of 113.5678392. And now how many sig figs do I need? This is multiplication and division. So it's sig figs that matter, which I've already said. And in scientific notation, you have, let me go back to the original number to get this, 3 sig figs and 4 sig figs. So your answer can only have 3 sig figs. So we're keeping the 113, and the number we are dropping is a 5. So we would round up, and therefore the answer would be 114. Questions?
I know what she says, but when I do second the comment, it just gives me a close break.
So for you, it's, so on the TI-89 titanium, you don't actually have to do the second comment anymore, it's just a PE button. So it depends upon what, look at your calculator, when you get your calculator out. If you can't get that answer, come see me, let me make sure, because all calculators are different. What I was describing is most people still have TI-83, TI-84s because they're cheaper. And if you have a TI-83, TI-84, that is how you would key it in. But if you have something that is newer than a TI-83 or TI-84, then come see me because I'll have to look at your calculator. Because every calculator is a little bit different. And they've tried to make things easier in some regards. Okay. Let's look at another problem. Any questions about multiplication and division? Let's look at a multiple order of operation problem. 118.7 divided by 2 minus 35.5. Okay. You have multiple orders of operation because you have multiplication and division. Which would say total sig figs. And you have addition and subtraction, which would say decimal point. We're going to have to do these according to PEMDAS. So we're going to do what's in parentheses first. So 118.7 divided by 2 gives us a value of 59.35. But what is the rule for multiplication and division? Total significant figures. And how many significant figures do I have that is the one with the fewest? I only have one. So because I'm not allowed to round, what I do is I write the 1 in a normal notation. But because I'm not allowed to round yet, I drop the others so that they are subscripts. That way I'm not rounding, but I can remember I only am allowed the one digit there. From that, I'm going to subtract out the 35.5. Which gives me an answer of 23.85. Huh? I didn't change it in my calculator. It's still 59.35. I'm just making note that I'm allowed 0 decimal places and only 1 sig fig. And it's just a method of notation to help you remember how many sig figs you are allowed. So what I know is I'm not allowed any decimal places and I'm only allowed 1 sig fig. So I would record this. So that means this digit is the digit I'm dropping. And my answer would have to be recorded as 20 with no decimal point, because how many significant digits does that number have? 1. Or you can record it as 2 times 10 to the 1. Okay. I love that question. Thank you for asking it. Why would I put 20?
Because there's no decimal place, so it doesn't actually count as a significant.
There's no decimal point, so the 0 doesn't count as a significant digit. But why did I not just record it as 2? Because I need that placeholder. 20 people is a lot different than 2 people. So you can't just give me the 1 digit and be done. You had to record it as 20 with either no decimal point, which means there's only 1 significant digit, or you had to record it as 2 times 10 to the 1, which means there's only 1 significant digit. Now, in this particular one, you would have gotten lucky probably one way or another, but not always. So it's always better to follow the rules and make notes about what was acceptable. Let me do one more. We're gonna do 99.0, whoops. Plus 2 times 5 point, oh, let me change that slightly. 2.0 times 5.56. So you're going to do what's in parentheses first. So 2.0 times 5.56 is 11.12. How many significant digits am I allowed? 2. So I'm going to make that as 11.12. Just so I know I'm only allowed 2. And from to that, I'm going to add the 99.0. And you get 110.12. This is addition and subtraction. What matters in addition and subtraction? Decimals. So this answer would be 110 point.
So only what's in front of the decimal?
So why did I only record what was in front of the decimal? It came back to here. And that had no decimal places left. That one is,
But the 110 is not as.
right, but what matters in addition and subtraction? The decimal. So that's why I went ahead and put the point there. Is so that you knew that we had to keep everything to the left. Little nuances. It gets tough when you start doing multiple orders of operation. That's where it's tricky.
Confusing me is you have 2 significant digits, but the answer ends up being having 36.
Because, well, this only allowed 2 significant digits. The next step is addition and subtraction. In addition and subtraction, it's decimal places that matter. So you have to, again, it is confusing because you literally have to think, okay, this is multiplication and division, so total sig figs matter. That's why we only kept 2 sig figs. But we kept this just in case it caused a rounding error later. We didn't want to throw it away in case there was a rounding error that would have been caused. But then we're into addition and subtraction, and with the addition and subtraction, it's decimal places that matter. This has no decimal places. This one does. So since this one has no decimal places, our answer cannot have any decimal places. But everything to the left is still valid. So in addition and subtraction, you can have 30 numbers to the left. It's only the decimals that matter. Is that clear? Takes time. Questions? Ask questions. It is tricky, but you literally, if you'll make notes as you go along and then use that rule for the next step. So I used the rule for the first step, that gave me this. I used the rule for the second step, that ultimately gave me this.
So like whatever we end on, that's what we're supposed to use. So like if we end up in addition, we're supposed to use this, even though it has both in there.
whatever rule you end on is what your answer is going to be, related to. However, you can't disregard the other rule, because if I had disregarded the previous rule, I would have had decimal places here. And it would have given me 110.1, which would have been the wrong answer. So you cannot disregard the other rule. You just have to include that rule as you go. But then each step has its own rule that you have to follow. Hold on, folks, I can't hear.
11.12 didn't have, because 0.12 was the existing one, 11, and we add, we can't put the 0.12 there. because we put the parentheses what we get. We don't have it.
That's correct. Folks, you cannot round until the end, because you can get rounding errors that will give you the wrong answer. And that's why I recorded everything, each step along the way. So go ahead and pass your cards down to the end if you're wanting in the grouping. And I will pick up the cards. Okay, folks. If there are no other questions, you can ask me questions, but otherwise you are free to go for today. There's a mouse down here. Wow, really. It's a watermelon full of that. Okay, you're going to have to do it. Okay. Because so you're gonna have to use your parentheses and not put it in parentheses. Because it does not have the BZ button. It doesn't mean it can't do it, it's just you gotta put it in parentheses. Any books? You probably can find, if you look at multiple orders above, or multiple operations, significant figures, you probably can find some tutorials. Okay. That's the easy on here, so just write your main. So I record all my lectures and I, post them after the recording, after the class.
No, like my calculator wasn't working.
That's okay. Okay, if it's not, if it's anywhere but the last digit, so if I had a 5 and on the very last page, if you had a 4, that's okay.
Okay, so
It's only if it's the last one.
thank you.
Oh, yes. I put it like that.
So, work.
Work 25 to of what is divided by 3.9. Yeah, this was just, little problem.
So you might have put times 10, carrot, or something in there. You don't have to do that. All you have to do is, you just have to put this number and that number with the 70. I haven't
I got somebody at.
Okay, so the reason I use active is at the bottom of the screen when you're doing the homework, there's a button you can click. And that button will take you to OpenStax textbook. That way you don't have to get the textbook if you can't. Because I'm trying to be cognizant of students' financial.
So we didn't have to.
No.
They told me I had.
Yeah, it's a, sorry, like I said.
Well, the other two classes are, there's 3 of us who do fundamental.
Can we look it up on YouTube?
They probably screwed mine up.
Because I don't get it book first. I have Mr. Taylor's class and his chemistry board, but I've never done chemistry before.
Okay.
So will I never be able to access that book again?
You're able to access it for us for the year. And technically, that book is gonna have much of what we are discussing. You would just need to ask me what chapter are you on. It's like right now, we're on the E chapter.
Yeah.
So everything that we've been discussing would have been in the E chapter for Dr. Taylor. College the more. And so if you'll ask me, I can tell you what chapter we're actually in, and because there's a lot of, it's entirely overlapped between the 2 classes.
Yeah, it's just the beginning of things. Because he started talking about everything. We got like prefixes. And you're gonna need to remember all this, but you should already know this. And then he went over there and I went, I'll just.
We're gonna be doing prefixes.
Okay, well, I already have all the notes for it.
I know that, like, for example, the 99.0 that, is that 36 or?
That is-
Okay,
So
so,
it's zeros at the end of the number. After the decimal.
so zeros before the decimal, they're not significant.
For a decimal number or for a number that has something. So in other words, 0.0002, the zeros before that first non-zero are non-significant. So you don't even start counting until you get to the first non-zero.
Like, you said. So.
All of those zeros are not
So until you get to your first,
non-significant, non-zero.
then that's when you start counting them. Okay.
No, because there's no allowed for our class.
If we're like a non-decimal one, does this count?
It depends on if there's a decimal point or not. In this case, there is not a decimal point, so that zero does not count. But up there, where I have the decimal point, there are 3 significant digits. Because I recorded the decimal point.
Okay,
So.
but if it's like
This is the problem.
reverse,
The first thing to hear.
so that doesn't count until you
That
get
is
to that.
correct.
Okay, thank you.
No, if you go in
to access using Blackboard, it'll take you directly to
And
the
then
class.
what's the lowest that's?
So you just gotta go through Blackboard.
Yes.
Thank you.
Okay, I think we're working on that. I was just confused about how
So.
there's only one significant.
The 1, 2 low isn't.
Because that's the lowest one.
Well, first of all, you can't, I had to do this. This is and you have 4 significant digits divided by 1. So that's why there's only one normal number, and the rest are all subscripts.
Right.
Oh.
Because
Okay,
I was only allowed one
It's like-
significant digit.
okay, so technically there's 4, but when you divide it,
But
there's
it's not
only
really-
one.
Well, because that only has one.
But if it's got 2,
Two significant figures.
That's correct.
0.12.
Okay, so you,
That 0.12
no.
only to add to the-
That is correct.
Okay, I was so.
Within that 1, 2 disappears when we-
How did they know? So this
So
one has
after that,
2.
what you're really looking at to find out whether.
Correct.
Your decimal is
Okay.
correct is 99.
Oh, so you got the problem. Oh, that's.
So which one is the lowest?
So I count, well, no, I counted those in parentheses first. I counted those in parentheses first, so this one had 2 to 3. So that's why I only allowed
Just
2
go there
to
because
be
I
normal.
think it's okay.
The rest is dropped. And then I did this math where I had 1 decimal and no decimal. So my
Your
answer
decimal
is
is not
no
because-
decimal.
Can you drop some?
Because I was only allowed 2 significant digits here.
Okay, so sorry.
So that's 2 right there.
Lowest not significant.
Okay.
It's
The
2.
multiplication and division, it doesn't matter on
Lowest
the
not
decimal.
significant is also.
It only matters to the significant. So since this only had 2,
our
So why
answer
do
is
we-
85 in that situation.
So why do we change over having 2 significant besides?
Because all things are talking about the
Like this one has 3.
And-
But this one has.
because it's always the one.
Okay, that's right. I was just-
But in this case, we have something happen.
It takes practice.
Yeah,
Especially
I
when you
really
get
never
into,
take.
when you get into the fixed operations, that takes practice. If you're just dealing with multiplication and division only, that means if you're dealing with just addition and subtraction only, that
Just drill it like that.
it's when we get into the mixed operations where it gets complicated.
I don't know why that makes sense, but
Yes.
So, you got the,
you just have to remember it. Just-
like, you see how this one
Unless
is
it's-
like 2.
That's all I'm saying, ask her about if it was like 2.85, if it was just 2.
So I kept the 5 normal, in the 9.35, I brought down.
So, do you do that, like, you only keep the first 2? But most you drop one.
Repeat that.
So like, you see how this one has, so like, you can go 84, so like, what could you drop the number?
What if it's just 2?
Okay, because you have to always drop, the number I am always making a subscript is what comes after. So in this one, the 11 was the first 2 digits to match the
Yeah,
2
I see
digits.
where you're from. I was.
So that's why those are.
That's correct.
Over here, I was only allowed 1. So that's why the 5, even though it doesn't look like it here, that's why the 5 was a normal number.
That's what we're looking at the first one.
Yeah, I just wrote.
So we.
Because we only have one significant.
Okay, yeah, the whole, and the test, the test not open, we don't pay. And like,
Yeah.
You have 24 hours, or, well, you have
I can answer this.
8 to 16 hours, come. Wednesday.
Oh, so it's.
Oh, you just take it on your own time, but you have, once you open it, you only have 45 minutes to complete it.
Okay. You got other videos.
Yes, so there's the lecture videos, plus I've been, posting all the, there's the flipped classroom, and then there's the in class. And I've been posting that.
Everything.
Thank you. I should have wrote it down, but I was just double checking, so this 0 does count.
Does not, just because there's no decimal shown. If you'd have put the decimal point, then there would have been that 0 would have counted.
So only 2, and then this one does count.
That 0 does not count because you don't start counting until you get to a non-zero.
Okay.
Because I was only allowed that 9 is technically dropped. So I did not put the decimal in there to indicate that I was only really allowing, I didn't have any, it comes down to what it adds up to. In this particular case, because it's subtraction, it was only 20, and therefore there is not, bleh.
And also it's like,
It is hard to explain. When I looked at this, because this is subtraction, I wasn't allowed any decimal places, so there's no decimal places. But because I only had one significant digit here, I only had one significant digit in the answer too. If it had been 27, it would have been 30, because I would round it up. Down here, 99 and 11 add up to 110. So by the rules, it's 110 with the decimal, because I wanted you to know that I wanted you to know that what's to the left of this with this one, this has no decimal places allowed, correct? So my answer could have no decimal places. But I needed you to know that this added up to 110, and that 0 was still significant. So it's the question of whether the 0 is significant, or whether the 0 is insignificant, or whether the 0 is significant. In this one, it was significant because of the fact that 99 and 11 add up to 110. And I needed, this being addition and subtraction means that it is the decimal places that counted, which means there is no decimal places left.
so switch to on that after now, and it's on, is the next. So, small thing, the difference. So this is the difference between all of them. Say how much you understand. You understand that, right? It's not the other. So we keep a total as part of the equation to ask. Right. And so, since we have them together, it equals one half, then we just come back to the part where the smallest, we have no decimal place. Because we have two single numbers. So now it's taking out to figure out in addition to decimal points. We to look at 99.0 and just